at some elements of object-oriented programming, kind of starting from what a class is and going on from there. There's a lot to this really. You can go kind of as far into it as you like, so we're just going to cover some basics, and then I'll probably record another screencast with a little bit more later on. So I've created a new console application. I've called it OO Cars. Cars are kind of the example that everybody uses because there are a few things you can demonstrate. So let's create a really simple program first. Let's put a console read key at the end, just so that, as before, if we just run it, it'll wait for us to press space at the end. And then let's define some variables for the make and the model of a car. The engine size in litres maybe, and maybe the colour. What else could we there's all sorts of stuff that we could kind of include that are attributes of a car, right? And what we could do here is to do console right line. Let's do it that way. Okay, and let's put our make, model, color. Yeah, make, model, color, and our engine size in. And let's just run that. Car 1 is Ford Fiesta Red, 1.4 litres. That'll do me for now. That's kind of enough to be starting with. Now you can see if we wanted to have a list of, or a database or a group of several cars, that we're going to have to repeat these variables here. Well, if we wanted 10 cars, we have to repeat them 10 times. That's obviously a lot of duplicate code. Let's put in an example of a second one, just so you can see what I mean. We obviously can't use the same names again. We could redefine them with maybe a 2 on the end if we wanted to keep them all. So you can see this is quickly going to become a mess. We could use an array for each one. That's going to get even more confusing. So let's make this 1.8. Let's do there we go. Start. So now we've got 2 cars being returned by our program, but we've doubled up all of our code. So the idea behind object-oriented programming is to represent things in code as if they were things in the real world, because quite often that's what you're modeling. You're modeling a real system that it may not have physical moving parts, but it will definitely have logical moving parts. So you can think of a class as if it is a template which is then used to create objects. So let's say these are the properties or the attributes that make up a car to us at the moment, and let's add a class. So if we right click on our console project and we do add class, it'll open the add item wizard, but it'll open it for us on class here. So we've got class. We are going to look at interface a little bit later as well, but for now let's do car. So in our namespace it creates a class car. This could be public, visible to anything that includes our namespace. It could be private, visible only within our namespace. It could be protected, visible only to things that inherit from our namespace. And it could also be static. A static class is a bit of a special case, and it's something that cannot be used to create an object. We're going to leave it with no modifiers to start with. So there are our variables we want to define. These would be called member variables or instance variables if you leave them here. But what we're going to do first is have a little think about this, and we're going to say, well, within our class we need a constructor. So the constructor is called when an object is created from the class. That object's called an instance. When you create a new copy of a class, it's an instance. So it follows the template that's in here and gives you an object. So let's create some properties on our class which allow us to get and set some values. In the latest versions of C# you might do it this way. Public string make and that allows us to get and set it. If we wanted to do something a little bit more complicated, which I'll show you in a second, we can add more code. But for now, let's say that our make, model, and our color are just strings. It's probably not right. They should probably be enumerated types, but it's not really important for the purpose of the demonstration. So engine size, I'm going to do something slightly different with. Down here, I'm going to do public decimal, because it's a decimal. Engine size, get and set. So you can see that this maps the same as this up here. And I'm going to have a private decimal underscore engine size. Okay, so this is my instance variable. It's a copy of the engine size decimal that nothing apart from my class can see. And when we get engine size property, I'm going to return that value. But when we set it, I'm going to add a little bit of validation. So I'm going to say if value, which is the name that it's always given when it comes in, because you see you don't get an argument name when this is called a property. When you set a property, it's always called value, the argument. If value is less than I'm going to say just less than 0 actually, because it's just for can't find the one I'm looking for. I think I'm missing an include there, so invalid operation exception. Or exception. Let's not overcomplicate things. So, and here we would do save the value. So you can see if we want to put extra code into a property, we can define it in this sort of full way. And if we just want our simple getters and setters, we can do it this way. I've got a plugin called GhostDoc installed, which lets me generate little XML comments on these very quickly. They do sometimes need a bit of editing, but by and large, there we go, right, documentation. So we've got a car which has all of these attributes. So now we can do this. So all I'm going to do is to replace our okay. So you see I can set and I can get the properties of my class with very little difficulty. And I can have my two cars. Someone's probably going to point out at this point that there's still sort of the same amount of code in this program. That's probably true, but we've not really repeated ourselves as such. And we could condense this now a lot. I'm deliberately kind of going in small steps, right? You can see we're getting rid of these nasty 2's on the end of all of these. Okay, so 2.color, and this is car 2.engine size. Right, and let's just demonstrate that working as is. No, what have I done wrong? Oh, I forgot to take the 2 off there. Right. So this should do exactly what it did before, right? There you go. Boom, boom, same 2 cars. We could easily add a third by copying this down. I'm not going to bother in this instance. Probably important to note at this point that when you define a variable that contains an instance of a class, so in this case my car, and you can see I say, well, this is the type, it is my class is the type, I've defined my own type, this is the name of the variable, setting it to a new instance of my class. Yep. Down here, if I do, so let's say instead of defining a new one here, I reuse this one. It's important to remember that I've then lost the original. I've overwritten the values because that variable that points to my class, I can't now get, you see, the Fiesta back. It's gone. Even if I copy this line down, it's just going to print out the vector again because I've changed the values in that specific instance. The car1 variable is just a pointer to an instance of car, and I've overwritten the values in it. So that's maybe a little bit different to how you think of ordinary variables, for want of a better word. So let's just pop that back how it was. Okay, so we've got a car class, we've got some basic properties in it. We're still repeating all of this code, so if we change the name of one of these properties, we'd have to change all of these. Let's put a third one in, so we can make our example a little bit more complicated. Okay, and this will be a BMW 320D. There we go. Right. Okay. So car 3 is, and this is getting a little bit sort of laborious, isn't it, to update each time. We're going to show you a way to deal with that in a second. So let's say, well, that's a third one. So let's just demonstrate that working actually. There you go. Okay, so now we've got 3 cars. Let's go back to our class. And the other thing you can do with classes is to add, obviously, methods. In this case, we're going to add a public method, which returns a string. We're actually going to call it toString. We could call it getTitle or something like that. Generally, toString returns a string representation of an object. I think maybe I might change that actually just to avoid. No, we'll leave it like that. And what I want this to do is to return string format. And you may have figured out where I'm going with this, but I'm going to grab that. Okay, and I'm going to chuck it in here. So I'm going to get the details, kind of the title. I'm going to, I mean, this could also be a property because it's just returning a value, right? So we could demonstrate a get only property. Let's do that. Public string title. Get only. We'll come back to methods in a second. Let's grab that. So a property doesn't always have to return a variable. So let's do in here, we want this dot make, this dot model. So this represents the current instance of the class. This make model color and engine size. Okay. So we've got our title property. So now here we can just go okay, a little bit of copy and paste action. And there's our third car. Missed the second one out somehow. Okay. There's the second one. Let's just build that. And you can see we've got the same output, which is fine. Let's define a generic list of type car. So list is a generic collection type. It's included with this namespace. We'll look at that more in the future. It's basically an array that's easier to add and remove from. So let's then do so we're going to add our cars to our array, or our list. It's a list, isn't it? Then we could consolidate this. Okay. Let's put a little loop in. So we're going to use the indexer there. I'm actually going to do I plus 1, so I continue to get car 123, not 012. And let's just run that. Right, there you go, exactly the same output, but you can see that now we're setting up our objects here. Ta-da. Now if I just stick a breakpoint on here to show you what it looks like in the debugger. This is our list of cars. Contains, effectively it's an array for all intents and purposes for this demonstration. Each index contains a car. You can see the private variable, and you can also see all the public properties here. So there you go. That's kind of how that works. Now you can also have methods, as I was kind of going into before. So that's a get property. You can also have methods. What about if we had something like, well, let's move away from the abstract, get a little slightly more abstract, sort of sillier example. Let's have a void method, so one that does stuff but doesn't return anything. Start engine. To support this, let's go up to where we have our private decimal engine size. I'm just going to, I prefer to keep these right at the top, so I'm just going to chuck that right there. Right, okay. Let's have a boolean for the engine running. When we create our instance, it's good practice just to make sure you know what state your object's in. So let's set engine running to false. And in here, let's go engine running true. Okay, and let's add another public property, public bool. Let's call it engine is running. Now you may be, oh, that's a typo there. You might be wondering why we use a method, not a property, when we could just have a property and we could set engine is running to true. Let's do dash, put a 2 on there, and here let's go cars I.engine is running. So if the engine's running, we'll get a little printout. So we've got our instances there. Let's do car 2 dot start engine, and just to prove a point, if we do that, that is actually the 012, third item in the array. So 2 and 3. Yep. So the last 2 should be running, and that'll just prove it doesn't matter how I approach that object, it's going to update it anyway, and there you go. Right. Why would you use a method instead of a property? Because you might want to do other things here. So instead of just setting a value, you might want to say, yeah, check engine is not already running, check the right key is in, and then maybe check drive, check all the seat belts are being worn, check doors are shut. So you can see you might want to go off and do a lot of other work in there to make sure everything is kind of happening. And generally you wouldn't do things apart from set a value in a property, because a property is really just a publicly available variable. So you can also have static methods. So a static method is a method that applies at the class level and can be called without having an instance, so without creating an object. An example, and this is getting a bit abstract now, we might have a public static string get new registration number. So let's do a random r equals new random. We'll just event one, and what we'll do here is do return r dot next. Let's do this string dot format. Let's put an X in the front just because we can. It's an example, I suppose. Right. Because if you think about it, to get a new registration number for a car, that's code that you might want to have against the car object. But you wouldn't necessarily want to have that method on the instance. It kind of belongs outside that. So you might say down here, this. So there you go. We can call it without an instance, just on the class itself. And we can output the result. There we go. So that's a static method. It's probably easier to show you a couple of real world cases where we use those. That's the basics. You can begin to tie in enumerated types and other things like that. So you might have one for color. Instead of it being a string, you might make it an enum for color. And then the last thing to look at this time is basic inheritance, which comes up in the exercise as well. So we've got our car class, but maybe we're thinking that I don't know, maybe we could have type of car, can we, hatchback or saloon, and maybe they have a different number of doors for argument's sake. So let's go to our car and let's add a property here. Let's do a get only property, and let's say how many doors does it have? Public int number of doors. Get. Now we could make this a get set property that can be read or written to, but then whenever you define any car, you have to set the number of doors, and the majority are probably going to be the same, aren't they? You know, let's return 4. A saloon's got 4 doors and a boot. Let's return that. Okay. So let's pop that into our title as well. Let's pop into our title. Just do 4 door like that. Okay. And in here we do this dot number of doors. Okay. So now you'll notice that, there you go, they're all 4 door, which is not actually correct. The Fiesta is 5 door because it's a hatchback. So let's add a new class. New class, like we did before. Hatchback. So our hatchback, here we're going to put a colon. Inherits from car. Let's give it a constructor, because we always give them constructor. Okay. Public int number. Well, before I show you the clever bit, so let's make that a hatchback now. So silly, right. Let's output the type there. Okay. Cannot explicitly convert car to hatchback. What's that all about? I've tried to put one class into another. You can't do it that way around. You could put a hatchback into a car, which we will look at later on, but you couldn't put a car into a hatchback. Right. So let's build that. So all 3 are still cars. You see, it's going to let me put it into this list of cars because it's a subclass, a type of car, and you can see the types where I'm outputting down here, get type. You can see that in my program that comes back. We have a hatchback, which is our 4-door, Fiesta, which is odd, and 2 cars. Okay. So now, in here we're going to do public int number of doors. Where's a hatchback? So it's got 5. There are different ways you could approach this, right? This is let's compile that. Oh, I've got a warning. So it's gone green here. That means we've got a warning. What's the warning? Number of doors hides inherited member. Number of doors. Use the new keyword if hiding was intended. Right, so we do public new because we're deliberately overriding property. What we could do here is go base.number of doors, and we can get to the parent one, which I will possibly demonstrate a little bit later. So there we go. Let's run our program now. Oh, that's interesting. It's still come up as 4. What's happened there? Well, what's happened there is that we're putting it into this list of cars. So we are treating it as an instance of type car. If we change that new to an override, oh, it doesn't work. What's this all about? So the problem is that we've got our car class and we've created a child, hatchback, which overrides one of its properties, but by adding a new method with the same name, that doesn't achieve I knew Eric would get involved at some point. It doesn't achieve what we want because in our program we're casting it back to type of car in our list. Now one way to do this would be in here to say if it's a hatchback, treat it as a hatchback. But an easier way is to use override, but that doesn't seem to work. And it says we can't do it because the original is not virtual, abstract or override. So let's go in here and let's go public virtual. So we're saying this is not really a property that's concrete. It's here, but it can be overridden. We start our program, and you can now see quite clearly here we have 5 doors, 4 doors, 4 doors. So now that this is virtual, it allows us to override it in our hatchback. There's one kind of last thing I'd want to look at here, which is saying having car and a vector is just a car and this is a hatchback. It doesn't make that much sense. So what I would quite like to add here is for this to become an abstract class. An abstract class is one you can't create an instance of. So now we get 2 errors. We can't do that. We can't create a car. So let's add a class for saloon. Extends car. Not going to add any code to it yet. Pop back to our program. Let's do that. Oops. Right, compile. So there you are. Hatchback, saloon. 4 doors. We've got our method start the engines. We've got our get new registration method that shows you a static method. We could override that static method so it does something different on hatchback and on saloon, but we'd call it accordingly. It wouldn't be on car anymore. That's a reasonable example of sort of basic inheritance. We'll look more at the different types of inheritance, I think, in a little bit, because you don't necessarily need it right now for what you're doing. But hopefully that will help to clear this up a little bit. And you can see you could add other styles. We've not created a class for, say, Ford or for Vectra. I mean, we could do, but in reality they're probably going to be adequately described, and you want to keep your classes fairly sort of generic and central. So yeah, there you go for now. See how you get on with that. And if you've got any questions, just ask.